Now let's take a step backwards and just remember that probability can either be experimental or theoretical. Now we focus a lot of the time on theoretical probability. That's where we just use logic to work out the chances of something. So a good example would be a coin has two sides. Logically, the coin is equally likely to land on either of those sides, and so we can say that the probability of tails is 1 out of 2, or 50%. Experimental probability, on the other hand, is applied to situations where we just can't use logic. We have no logical way of knowing what the chances are that it might rain tomorrow. Or if I go to throw this pen into the bin, we can't say logically what the chances of me making the shot might be. We have to say, well, how often does Miss Stanton make the shot into the bin? Or how often has it rained before when the clouds look like this? So we gain data about experimental probability by either running an experiment or by just looking at what's happened before. And if we've looked at what's happened before, we need to say how many times has it happened? And that's where this term frequency comes in, how many times something's happened, or relative frequency, which is the number of times that an outcome has happened compared with the total number of outcomes. So if we want to know, say, the probability that I'm going to make that shot into the bin, then obviously if I make the shot 10 times and I only get 3 of them in, it's reasonable to say I have a 3 in 10 chance of making it when I make my 11th shot. Obviously, the more trials that we do, the more reliable that data gets. If we want to know the chances of rain tomorrow, then we need to compare today's weather patterns and clouds and everything that's happening out there with all of the other times that it's looked a lot like that. And we have to see how many times it rained compared to how many days there's ever been that looked a lot like that with the weather patterns, and then we'll have some understanding of why it might be a 15% chance that it will rain tomorrow. So, some notes here for you to write down. The probability distribution tables and functions that we just saw, they all work off theoretical probability. That's the one that's derived by just using sheer logic. But sometimes we can't apply logic to work these out, and we have to use experimental probability, which relies on analysing the frequency of any given outcomes happening in the past or perhaps in an experiment. Now, relative frequency just compares the number of times that an outcome has occurred with the total number of outcomes. So we get that then as a fraction. We can convert that to a decimal or percentage, and we think of that as a probability term. It's really just looking at relative frequency though, but we can use it to estimate probabilities. Important that you remember though that it is an estimate. Now, we can accumulate these scores just as we did with the theoretical data, that means add them up. And we can draw the histograms and the polygons that we've just drawn with our relative frequency data so that we can find those functions that go with them. But, important thing to remember, just because something happened before, that does not mean it's going to happen again. So if we increase the number of trials or we look at more and more situations that are the same, then we're going to have much better reliability in our data. And in fact, the same sort of problem occurs with theoretical probability. Just because I have a 1 in 2 chance of flipping heads when I flip my coin, that doesn't mean that I'm going to get 5 heads when I flip the coin 10 times.